Welcome to the Release Night is an anti-pattern, using progressive delivery to safely release during regular business hours. I have a question for you. Is this the right way to release software? That is a big pile of empty pizza boxes stacked up in a conference room late at night. It's a sight I remember well from a time not so far away. Would you do this every day? Would you do this every hour? My name is Dave Karow, and I don't miss release nights at all. In my past lives, I've been a systems trainer, a project manager, a developer, and a product manager. Now, I get to spend my time sharing ways to do away with a release night, get your personal time back, and ship more meaningful features with less drama. So, let's get started. An anti-pattern exists when two criteria are met. First, some repeated pattern of action, process, or structure that initially appears to be beneficial ultimately produces more bad consequences than beneficial results. So, start out with good intentions, but over time becomes less useful. The other half that has to exist is a refactored solution must exist that is clearly documented, proven in actual practice, and repeatable. So, this is the good news. There's already a better way, and it's not some black box mystery. The release night and the Big Bang release are synonymous. A very large collection of work is deployed and taken live all at once. No matter how much testing you do, things are likely to go wrong. And since it's such a big collection of stuff, figuring out what caused the problems and unwinding them, doing the triage, can be tough. Doing that triage and repair when your site is down or when the end of a maintenance interval is approaching can be crazy stressful. So the refactored solution is continuous delivery. Let's look at this image first. There's a regular flow of small scoped packages making their way to production. Since each is small and they come along fairly often, inspecting them is easy and knowing how to take them live is much less daunting. If we zoom out a bit, this is really about creating a predictable path to production that relies on automation of a consistent and proven set of steps. The tips I'll share today have a lot to do with the release to user box at the end and the implement box at the beginning. First, let's look at a common trap of sort of doing continuous delivery. If you frequently have to stop your delivery pipeline because production is frozen, changes will pile up and you're really heading right back to the Big Bang release territory. Let's talk about ways to make that much less likely to happen. I like to call this section achieving more flow and less, oh no! The main goal of continuous delivery is to achieve flow, a state where value moves into production frequently and the time between a code commit by a developer and code working in production is measured in hours or minutes, not days or weeks. Oh no probably needs no explanation. If doing a release causes disruption, it's painful. The gut reaction is to do releases less often. We need to make releasing less of a big deal and less risky so we can do it more often without doing bad things to our users. The main strategy I'm going to share today is progressive delivery. I'll share some other complementary tips too, but this is the critical foundation for getting rid of the release night. This strategy starts by finding a way to decouple deploy from release. You need a way to push code all the way to production without it being executed. Next, you need a clean and reliable way to expose new code to a subset of your users, starting with the dev and test folks, moving on to internal users, and only then to a subset of your actual customers. The critical third requirement is to have a way to automatically observe the impact of the new code on system health and user behavior. You do that by comparing the experience of those who are exposed to the new code with the experience of those who are not. Finally, you need the ability to easily expand or contract the exposure based on what you see in your observations. Let's look at what a release looks like when you're practicing progressive delivery. First, you deploy your code to production. It's there, but you've not exposed it for execution yet. Next, you begin to turn up exposure. At first, you do that for your dev and test team so they can check it out one last time in the actual production environment with production data, production infrastructure, etc. Next, many teams expose internal users, which some people call dogfooding and others call sipping your own champagne. Then you start exposing actual customers, but only a few. Your goal here is error mitigation. You want to find things you missed in prior testing and do so without impacting a significant number of your customers. If you find problems, you'll either dial the exposure back or test mitigations on the small population first. Next, we want to make sure that this change we are making actually has the desired impact. We want to measure that impact in a repeatable way that avoids bias. Our goal here is to confirm that we're getting the different user behavior that each change was intended to accomplish. If it's not helping the business, and especially if it's hurting the business, we don't want to roll out to more users. We want to address the issues first. After things look good from an errors and impact perspective, we might make one last stop on the way to a full release. Here we pause the ramp at 60 or 70 or 80% and watch performance through a peak traffic period. This scale mitigation step protects us from declaring done only to find the system falls over when it's fully loaded. Once we pass through scale mitigation, we can ramp to 100% and call the release done and successful. Now, a lot of what we just saw was dependent on decoupling deploy from release. There are a few ways to accomplish that, but if you want fine-grained control and the ability to easily tie impact to individual features or code changes, feature flags fit the bill very nicely. If you aren't already familiar with them, feature flags allow you to change which code path a user or session will pass through based on rules that can be edited instantly without a new deployment. Just think about making a function call, passing the current execution context, and getting back a decision from local memory about which code execute for the current user. Since the decision is being made in local memory, there's almost zero latency. There's no network traffic to make this decision. When it comes to observing the impact on system health and user behavior, the process looks like this. You change the state of a feature flag, you capture telemetry into an analytics platform, you assess the results, and then you decide what to do next. Just like everything in continuous delivery, the third step, assess results, is only really sustainable if it's highly automated. We don't really want to be doing a lot of ad hoc data science in the midst of a progressive delivery process. As you think about ways to do that observation, it's critical to find ways to separate signal from noise. Many things can influence user behavior and system traffic. There could be changes elsewhere in your product. There could be marketing campaigns driving various behavior by users. There could be a global pandemic like the one we're facing right now that changes how users behave and when they do it. Even nice weather could have an influence on whether a particular feature or a traffic pattern in your app goes up or down. When your goal is to evaluate your release, you need a way to get rid of all that external noise. The good news is that science solved this a long time ago. It's called the randomized trial, where you randomly assign participants between the new thing and the status quo. In statistics, they call that the treatment and the control. If you think that 18 to 24-year-olds will love your new feature, you send half of them through it and look for significant differences between them and those who got the existing functionality. Since you're evenly spreading them between the two groups, those outside factors are canceled out. You want to make these assignments both random and sticky. In other words, consistent across sessions so users don't flap between experiences, right? This can be accomplished by having a unique seed for each feature flag and then hashing the new key of the user with that seed. By doing a mod 100 to the result, you always end up with a number between 0 and 99. They get that number no matter how many times they pass through your code or how many different ways they got into that code, because it's deterministic. That key, that seed, that hash algorithm will always come out to the same bucket number. So here this is visually, right? For each feature flag, let's say this feature flag is about whether to show a new recommendations feature. Each user will be assigned to a bucket number. If we ramp from 0 to 20%, the first and third users in this picture here will be exposed. If we ramp to 50%, that would expose 4 of these users. Now, I know I've covered this random trial aspect rather quickly. If you're familiar with A/B testing, this is similar, but the focus is on all aspects of engineering impact, not marketing landing page optimization, right? So this is anything we're doing to change. It could even be something the user shouldn't see, like a back-end search algorithm. Anything we want to be able to roll out and observe whether it's working or not, this technique is super powerful. I want to share 3 tips that will tilt the odds in your favor for moving from a release night to progressive delivery during normal business hours. The first 2 tips will help you achieve small batch size. Remember from earlier that having frequent deployments of a small scope is the easiest way to achieve flow and to avoid the overwhelm and overlapping complexity that you get when you have a lot of stuff happening at the same time. The first tip for achieving small batch size is incremental feature development. You'll probably be familiar with this if you're a fan of Scrum and fixed duration sprints. The first thing you do is break a big feature down into small pieces that can be built, tested, and shipped over multiple releases. This approach lets you keep the user-facing bits hidden or latent until they're ready. And it also lets you expose any portion for testing and feedback right in production. The second small batch size tip is also a great strategy for gradually replacing legacy code with modern components without a big bang cutover or without two huge parallel projects where one doesn't go live until it's been worked on for months or years. It's called branch by abstraction. Imagine you have three parts of your app that all rely on some component that you eventually want to replace. We're calling that component the flawed supplier in this diagram from Martin Fowler's blog. The first step is to build an abstraction layer, which does nothing more but stand between one of the consumer bits and that flawed supplier. And you update the code of that one client app to call that abstraction layer. Eventually, you update all the consumers to be calling that abstraction layer, which at this point is still just a simple front for the flawed supplier. Next, you build the new supplier, the back-end process, and you configure the abstraction layer to route just one of the consumers through it. Maybe at this point, the new supplier only does a fraction of what the flawed one does, but it meets the needs of this one client. Once you've got support for all the clients, you tell the abstraction layer to route them all to it. Now you can remove the flawed bit from your app and your infrastructure. The key here is that feature flags let you control what happens in that abstraction layer without any new deployments of the abstraction layer or of the client code. We've pushed new versions of the backend to be sure, but we've just changed the rules being sent to the abstraction layer. This is just another form of decoupling deploy from release, really. Let's move on to the last tip, which addresses a question I get frequently during talks. What if there are data structures or data services involved in progressive delivery approach? What if I have a table or data service change that I need to accomplish in order to move forward? It turns out there are some well-documented patterns to decouple schema or service changes too. Traditionally, when there's a major database change or service layer change, the solution is a high-stakes release night. Whether you shut down for a maintenance interval or make parts of your app read-only, and I've done both, the idea here is to do the changes inside of a narrow window, right? So there's a lot of pressure to get it done. And typically you're trying to do this in the middle of the night and get it back up before you have major traffic. The pain points in the traditional approach are many. You have downtime to do the release. You have downtime if you need to do a rollback. You're probably going to be doing this migration over late at night or over a weekend. There's limited testability. You have very limited window in order to sort of sanity check to make sure everything's working the way it should. And if you do find a problem, you lose the transactions when you roll back. So things that happen during that initial cutover are probably lost. Progressive delivery can help us out here too. Let's look at the same migration but use feature flags to manage a gradual and much less stressful transition. First, we put feature flags in the client code so we can control where it sends its requests to. And initially it's just sending them to the V1 like it used to. Once we've stood up the new service, we enable what we call dual writes, sending data to both the old and the new service. The new service is in a light shade of green because it's only getting the new data. It doesn't have the historical data in it yet, right? And importantly, we're not expecting any response back from V2 yet at this point. Notice the green arrow is just pointing down into V2, but not back into the client. Next thing we do is we copy existing V1 data into the V2 infrastructure, doing any needed transformations or enhancements behind the scenes. We can take as long as we want for this step. Let's pause and just focus on that for a second. We can take as long as we want for this step. This could take hours, days. It could take as long as you want because right now we're still relying on V1 for everything that the users are experiencing, right? Now, I want to ask you a question. Has anyone in the audience, and you can pop this into the chat, has anyone in the audience ever been part of a migration where you had an estimate, which was, oh, we're going to need 4 hours or 3 hours or 2 hours or 5 hours or whatever to do this step while we're in read-only mode or while we're down. And then you get maybe an hour or 2 hours into it and the DBA pops up on Slack and says, hey, it's taken way longer than we thought it was going to take. It's looking like it's going to take, more like 8 or 10 or 12 hours. We should be back up by, say, 10 a.m. tomorrow, right? It's happened to me before. It's happened to a lot of people I know as well. Using this approach, there's never a need to send out a, hey, we're sorry, we'll be down longer than we thought status message because you never had to take the system down here. Once all the data has been populated into V2, we can move to what we call dark reads. So now we're actually pulling data from both the V1 and V2 services, but the front end isn't really acting on the V2 data yet, and the real customers are not dependent on it. In this step, we can confirm the scalability and the stability of the new service under full production load. If there's a problem with V2 here, customers won't notice because they're still being served by V1. Finally, when the scalability and data integrity of V2 has been confirmed, we simply transition the reads to V2 and V1 can be retired. This process can take place over hours, days, or weeks. Feature flags are what allow the real-time changes to where the client code points without requiring new client deployments. So, compared to the release night way of migrating, this one is significantly less risky and way less stressful. There's no downtime. We can roll back without data loss. We can migrate when it's convenient. We could even do this, Monday through Friday and then start it over again on the next Monday. Like literally, there's no need for it to be some kind of a mad sprint. You can test the migration with real data. You actually, because you're doing these dark reads, you can actually run tests on actual production data before you ever cut over. And all stages can be ramped to test scale. You can actually make sure you run this through a peak traffic period. So I hope this talk has helped you see that release nights are indeed an anti-pattern. There is a better way, and people are already doing it, documenting it, and repeating it over and over. Here is proof that it's working. So last November, my CTO at Split Software published a blog called On a Mission to Kill Release Nights. He published graphs showing the days of the week and the hours of the day that Split customers created and made changes to their feature flags. What we see is that the work gets done during business hours during weekdays, right? This is a graph I pulled that's just the hours of the day. If you look here, work gets done during the business hours, and it even takes a little bit of a break for lunch. The most interesting colors here are the dark blue and the light pink. Those are changes to flag configurations and kills, respectively. A kill is a bit like a panic switch, turning off a code path instantly. Changes could be ramping up or ramping down the exposure. Only a very small fraction of those changes are taking place outside of working hours. Now, to be fair, this is data from teams who are already using feature flags, and it just represents our customers, not the experience of homegrown feature flag users or users of other feature flag solutions. Still, there's a wide cross-section of team sizes and industries here, so I think it's solid proof the concepts in this talk work. When I wrote this talk, I drew from 2 books in the O'Reilly library. If you have an account on O'Reilly's online learning system, you can search these and download them. If not, you can download them for free from Split's site by just filling out a brief form. Here's how to find them on Split's site if you go that route. First, head over to split.io/resources and then filter it down to ebooks, and they'll be right there for you to download. Another useful resource is a ref card I wrote called Progressive Delivery Patterns and Anti-Patterns. And if you just go to split.io/resources and search for progressive delivery, you'll find it there.